We need to throw that around a bit.
What?
We need to throw that around in class today. Where's Star? Star.
What's up?
Candy.
All out.
Okay. What are we doing today? Finishing the practice test. Up. You're killing us now. See one. How bad is that? 5.5. I knew he'd win. Yeah. I voted for marijuana legalization. Really? Yeah. I'm like one of the 8 people.
No, I didn't. One
Like funny. So that's the party.
What does tuition cost? I was thinking.
I thought it was close to that at least.
Oh, I bet $50 a special year.
Where do you see the vote, Mike?
Because for Middle Tennessee State University, which is FTSU in Tennessee, in-state is 7,000, out-of-state is 4,000. That's a big jump.
You're not going there.
No, I'm not.
You're going to drop out after a semester and then come down.
No, I'm not.
It is tonight. Jack,
No, I did
Jack,
not.
I'll have to work tonight.
No, I didn't.
Good.
What a leader. See, I asked for Wednesday. Actually, I don't care less. He just shows up.
What'd you say, me?
Not you, Connor. Other Connor.
Oh, hi, Connor.
Idiot.
All right. Okay. All right. So first and foremost, yesterday we started the practice test. I don't think I've uploaded the video from yesterday. I need to do that just so you can watch it if you were gone yesterday. I forgot to do that last night. What we went through yesterday is 1 through 3. That's what we talked about. So if you have any questions today on 1 through 3, we'll do that at the very end. My goal today is to get through the rest of them, 4, 5, 6, and 7, to make sure that you know it. We also reviewed kind of like the notes we took Monday, which is based on like parallel and perpendicular. So that's something we're gonna we'll eventually discuss today. All right. So make sure you have your practice guide out. We're gonna talk about it right now. So let's scroll through this. We already did 1 through 3. We're going to continue on. Now, what I was hoping for is that you at least attempted to start number 4. You at least attempted it to see if we can get this, because I don't want to spend a lot of time on this today, but I do want to cover it for those people that are still getting it somewhat wrong. And that's why I was hoping you did attempt it, to see, did you at least get it right? What are you messing up on? That type of thing. The thing that I find the most interesting is people still don't know how the piecewise functions graph, which is, it boggles my mind, because they're just giving you a set number of things to plug into it. Like on this top graph, I'm only allowed to plug in numbers that are less than 1. So I'm going to plug in 1 to start with, but I'm going to have an open circle there. And then I'm going to plug those numbers in one at a time into this and kind of graph where it's going. What can you tell me roughly about this first graph? Curve line, curve. It's got an x squared, right? Anything with powers, like powers 2s, 3s, 4s, square roots, those are technically powers. You can graph that, but we need to graph at least a couple points to kind of see where this thing's going, right? All right, so the first thing I'm going to plug in, I'm going to plug in a 1. What's 1 squared? 1, and then you take it times negative half. Okay, so you get negative 0.5. So at 1, you get negative 0.5, and there's an open circle right there. Not closed, open. The reason why it's open, I'm not allowed to include it. Now I'm going to plug in numbers less than 1. So the next number I'll plug in, let's try 0. 0 squared times half, 0. Okay, so we have that. So that's a dot. Okay, let's keep going. Let's plug in negative 1. Negative 1 squared. 1. Take it times negative half. Negative half. So negative 1, negative half. Okay, so you can already see it. It's already starting to curve. Let's plug in negative 2. Negative 2 squared. 4. Take it times negative half. Negative 2. So we're here. So now you can start to see we're already starting to build and starting to do something like that. Okay, does that make sense? Okay, I'm going to stop there for that one. I think we've done enough where you can kind of see. If you do the next one, if we do like negative 3, we get like negative 4.5 or something like that. So you can start to see kind of where it's going to go. It's going to negative 4.5 is like right around here. So there you go. All right, does everyone understand the first one? How I have an open circle and then I plug in a couple dots and then it's just going to curve. Okay, now let's start the next line. I'm going to use a different color to kind of to show you kind of where this thing's going. Let's use red. So the next one, I'm going to start with the number 1 here, and I can include it because I can be greater than or equal to 1. So I'm going to plug in the number 1 for sure, put a solid dot there, and we need to plug it in here. This is the second equation. So if I plug in a 1, what's 2 times 1? Plus 1? 3. So at 1, we get the answer of 3, and that is a solid dot there. Okay? Everyone understand the first part? Okay? Let's plug in a number that's greater than 1. Let's plug in like 2 or something like that. So 2 times 2 plus 1, 5. So 2 times 5. All right, now, do I need to do any more dots? No. Here's the thing. It's a straight line. It's actually a ray, and that's something I want to discuss. That's something I've kind of noticed. A couple questions I had yesterday. Simple, innocent questions. How do you know that the arrow's not going both directions? It's a ray. It's a ray because they're only allowing you to pick numbers that are greater than 1 or equal. So it's a ray going that way because that's the idea. You're starting with 1 and you're going up. It's not going both directions. If it went forever, they would say from negative infinity up to infinity, and then you'd have arrows going both directions. So they're telling me that I have to start with 1 and move up. So that's why it's a ray. That's literally what I have circled there. In Algebra 1 class and Algebra 2, that is literally a ray on a number. So that's kind of the idea. Okay, now here's the question. Does everyone feel comfortable with that type of problem now? Like graphing anyway. Okay, what if I did something like this? What if I put a 4 here and I said this is anywhere from x is less than 6 to greater than or equal to 5? We understand what that's going to look like. Okay, constant numbers. Okay, so if it's just a number here, that means it's like a horizontal line. Horizontal. Okay? And all I have to figure out is what numbers I'm allowed to use. So maybe I'll go to like 16, let's say. So from 5 up to 16, the answers will be 4. Okay, for this particular graph, if I'm ignoring the rest of them. So what that means is there any x's I can plug these numbers into over here? If this is my equation. Okay, is there any x's I can plug in? No. So literally what that means is when I start here with the number 5, okay, let me get rid of this. If I start here with the number 5, my answer will always be 4. So at 5, 1, 2, 3, 4, 5, my answer will be 4. And it's a solid dot. I was allowed to include it. At the number 6, because that's a number just greater than 5. At 6, the answer will be 4. At 7, it'll be 4. 8, 9, 10, 11, 12, 13, 14, 15, and then 16, I'm not allowed to include it. It was an open circle. this is my answer. That's the graph. Because every number between here and here, every answer was 4 every single time. Does that make sense? Like it's do we understand that graph now? Everything else has tilt, it has curve, but for some reason I've kind of noticed from the examples I gave, that little quarter sheet paper, those pop quizzes we took, that seems to be kind of one of the challenges. Some people just don't understand that. Okay, questions, comments on any of that? Okay, for the test, you need to be prepared for any of these 3 types. Where it could be a line, it could be a constant, it could be a curve, wherever it's at. All right, but I need to go back to the original graph. I just wanted to throw that at you because I had this feeling some people wouldn't know what to do there. All right, so negative half, 0, half, 2, 1/2. All right, so that 3, 4. All right, or is it 4 and 5? No, that's 3, 5. All right, this one. All right. Okay, so now that we're back to the original graph, what's my range? Negative infinity. I agree with that. So range is the y numbers, right? Negative infinity up to 0. Then we have a break. So negative infinity up to 0, and do I include 0? Yes. It's closer over there. Then we have a break in the graph, so we need to do a union. And where do we pick up again there? 3 and go up. So 3, we include that because that was a solid dot, and it goes to positive infinity. Remember, range is y numbers. Don't look at x numbers. Okay. Any questions with that?
It's not with that exactly, but like if we lit on infinity, you must put positive.
Yes. Yep. Because I want you to know if you're going positive or negative. The big thing I'm checking for: are you using parentheses correctly? Are you using brackets correctly? Are you putting the numbers least to greatest? Are you doing unions if you need them? That type of thing. Unions only if there's like breaks in the graph, like literally breaks going up and down in the graph, like that. That's a break. Okay, questions? Something you're not understanding? All right, let's move on here. Let's take the interval where this thing is increasing. It's actually increasing a couple different times here. Where is this function increasing, decreasing, and constant? Now, would you agree that there's no constants on this picture? Right? It's not flat. Okay? There's no constants, so we're not gonna have any constants. So no worries there. But it is most definitely increasing. And how this works for increasing, decreasing, we're looking at domain numbers, not range. We're looking at x numbers, not y numbers. Okay. All right. So where's this thing increasing? Where's slope positive? Yeah, negative infinity up to 0, right there. And we're not going to include 0. The reason why is 0 shared, because it's going to start decreasing after that for a little bit, for like one step. It's going to decrease. Okay, so for increasing, I'm going to put them over here. So increasing, and this is how I put it in on your practice guide, right? So increase the interval negative infinity up to 0, and I'm not going to include 0. Now, it decreases for a little bit, then it starts increasing again, correct? It increases from 1 and up. We're going to include the number 1. We're going to include it because there is a solid dot there. It's actually an endpoint, and it goes up. So we're going to union. We're going to include the 1 for the x number, and we're going to go up to positive infinity. That's where it's increasing. It's going up, positive slope the whole time. Okay? Don't look at the arrows. For some reason, people think like, oh, this is decreasing. The arrow's pointing down. No. As you go left, right, it's literally climbing the hill. That's increasing the value. It's getting higher on the graph. That's increasing. Okay? All right. Now, where's this graph decreasing? 0, not including, because it's shared, right? To what, the number 1, not including 1. From here to here, this little band, it actually is going down. We were losing money for a little while. No constants, anything like that. Okay. Questions, comments on increase, decrease, step. The big thing I'm checking for, obviously, parentheses, brackets, unions if we need it. Understanding like you're going to put a parenthesis if it's shared, because things like that 0 is shared, so we're not going to include it in here 1. All right. Any questions? Again, if you're not quite understanding this, always come in. I'm here after school or before school if you want to go over some examples or just make up stuff and go through it. Or maybe after we're done reviewing here, we'll go through it. No, you're digging. All right, and then the maximum, minimum on this graph. It doesn't have an absolute minimum, because if you go back to that graph, here it was. Like this, there was no absolute minimum. There was no absolute maximum, because it went up to infinity. But it did have a relative. It did have a relative maximum. Okay, it's where you had a little, little camel hump, a little hilltop. Where is the hilltop at? Right at 0, 0. That's a relative maximum. So we hit 0, 0. That's a relative max. Relative maxes are any time in a graph that goes up or down, that's a relative. It doesn't even have to be the tallest or lowest point. It did a little kind of bounce. There's no minimum, no relative min. There's no valleys. What I mean by valleys, it didn't do something like this in the graph, like where it had an actual valley. It stopped at -0.5, but it didn't start going back up again. So there was no relative mins, but there was a relative max.
So infinities don't count as.
No, they're not. That's not an actual number. It's a direction, so we can't use it as an absolute max because there's no way to stop that. Yeah. If there was a dot, then yeah, it stopped here. Okay, that's a max. That's a good question. Any other comments or concerns? Okay, it's very explicit. I want you to know the differences, absolute versus relative. Book doesn't do a very good job of explaining that. Okay. All right, let's move on. We'll move on to number 5. We're going to split this up into 5 and 6. All right, 5 and 6. You have to use the graph at the bottom. Have that little bar graph, correct? There's males and females. Males are on the left, females are on the right. It's kind of color-coded, you can kind of see it, but how those bar graphs work, males always the left number, females are always the right number on each of those years. So the first one they want you to do is put that data on your graph, the rectangular coordinate system. That's the Cartesian coordinate system. That's what your book always refers to it as, is rectangular. So you need to take those data, and what we're doing is we're making a graph for the male expectancies, the males only, from 1960 and on. So if I scroll down here, I'll help you set up the graph here. Okay? So here's my information. So what we're using the years. We're using the years here. These would be the numbers. And it's years after 1960, right? Life expectancies after 1960. So we can start with that number if you want. Not a big deal. And then we're only using these numbers. These would be X. Those are the X numbers we're using, or the Y numbers, I mean. The answers coming out. And so really my graph, for these numbers here, I really don't need to be in these lower numbers, because what was the smallest number for these males? 66-ish. So I don't really need to go below 50. So what I can do is I can kind of put a break in the graph here. So maybe we'll start with going down the road here. We'll start with this will be 1960. And maybe I'll skip a couple, so because it looks like they jump every 10 years, so maybe every 4 I'll hit another one. So 1970, 1, 2, 3, 4, 1980, 1, 2, 3, 4, 1990, 1, 2, 3, 4, 2000, 2005 down the road, something like that. You just kind of bounce. You can set your graph wherever you want. These numbers going up, I really only need to start with 50 and maybe go up to 80. That's really kind of where I need to be, that range. So if I want to start with 50 here, I'll go 50, 51, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that's 60. 6, 7, 8, 9, so 69. Do I need to be higher than that? Or do we get to the 70s? We open up by every year or two. So 52, 4, 6, 8, 60, 62, 64. So this is the part that'll probably take you the most time. Just kind of setting up your table however you like it, just so it can display data. Okay, so there's my numbers. That's pretty much what I need to get to. And then what I'm going to do is I'm going to plot. So in 1960, it was 66 point something. Right? In 1970, it was 67 point something. And then I can keep going and I can keep plotting. So 70, 71, 70's up here, 71. It went up to 74. And what should happen here, if you did this right, it should kind of look like a bar graph. It's kind of going up. I know it's going to fluctuate, but that's kind of what it's looking like. Okay, does that make sense, like what you're doing? Apply your data. You can set it up any way you like as long as it's representing your data correctly. You're not, doing some weird stuff. Because remember, equal spacing is a big deal. Giving the correct spacing here, because you can kind of fluctuate. That's why I give you kind of an open graph so you can kind of label it yourself. Putting the labels, like this is the years down here. This is the life expectancy. So it's kind of nice to have labels on those so we kind of know where you're at. All right, now let's go through your questions. So that was problem number 1, right? That was set A. I'm kind of leading you through A, B's, and C's. We'll kind of walk you through what you need to do to set this problem up. So A. Set up everything you need. Part B, draw a line that connects the data through for the males from 1980 to the year 2000. So I'm going to get rid of my line here. So 1980 to the year 2000. Years 80, years 2000. I'm going to draw a line that connects them. And yes, I will give you rulers if you like. On data test, you can borrow a ruler from you. So there's my number. Okay, so there's my thing. So it is going up. Okay. So there's part B, and it wants me to come up with an equation and write it in slope-intercept form and standard form. So what I would do first is I would definitely write this in point-slope form and then rearrange. So, and what I'm doing here, how I'm coming up with point-slope form, this is my coordinates, 1980, comma. What's the number for 1980? 70, exactly. The year 2000. What's the number for the year 2000? 74.3. So those are my coordinates, and I'm going to do old school slope formula for that. Whatever the slope is, whatever that number is. So I know the numbers on the bottom will be 20, with my x numbers. But on the top, what is that? The difference of 4.3. So there's my slope. So plugging this into slope intercept form, or point slope form, I should say. My slope is what, 4.3 over 20 x minus some x number. That was my slope that I just found, finding the difference in y's over x's. And what coordinate do you want to pick on that line? Do you want to pick 1980 or the year 2000? 2000. Okay, so we're going to plug the x is my 2000, and my front number is what? 74.3. So there's that. If I want to get to standard form, the first thing I need to do is distribute fraction to get what these decimals are. Then I can multiply everything by 4. So 4.3 over 20x, and 2000 times 4.3 is what is that? 1, 2, 3. So it's 860 over 20. I can get rid of that, so it's 70 or 43. If I multiply that correctly. 430. Yeah, 430. Yeah. And minus 74.3. All right, and then the last step, move the 74 across, move the x across, because I think they want you to get it in standard form. I'll have to multiply everything by 20 to get rid of the fraction, multiply everything by 10 to get rid of all the decimals. So if I multiply everything by 20, you can figure out what that is. But they want you to get to your different forms. I always start with point slope form first, and then rearrange it to the other forms. Okay, so that's going to take you a little bit of time. But obviously you have a calculator in front of you, or you should use one to rearrange that. Okay, now why we do that? Why I want you to come up with these equations? That's what you need for part C. Kind of leading you through this. Part C says, hey, what's the life expectancy for somebody in 2020? Yeah, just plug it in. That's why we came up with this formula. Why I want an equation. Because it can help you predict. If you want to predict what will happen in the year 2020, plug a 2020 in here. That's your X numbers. That's the year. Plug 2020 in here and solve for Y, and it will tell you what your life expectancy is that year. That's why this is great, why you want to come up with these equations. So that's where you use your calculator. So if I take the difference, that would be 20 years difference times this, it's 4.3, add the 74.3 across, and you should get a number like 78.6. I'm doing the math in my head. Okay. Does that make sense? Like what you can...
How are they going to slow them?
Oh, the slope, taking the difference in the y numbers over the difference in x numbers. Just doing old school slope formula, the average slope, that's what they call it. Okay, questions, comments on how to do problem number 5? It'll be something like this. I'm going to give you some information, walk you through kind of how you're supposed to set up and how you're supposed to use it. This is like a real-life application problem, taking some data, predicting what can happen, like a question.
So in the year 2050, let's be 300 years old.
Sure. Yeah. Well, let's hope that it's that.
Technically, every year our life expectancy is going to go up. So you could look for it.
There's gotta be
All right. Questions, comments on number 5 here? Okay. Obviously, I didn't finish that last part where you had to write in the standard form. That's something that you should be able to handle on your own. You should be able to rearrange the equation with the standard. Standard is the ax plus by equals c. Remember, the a, b, and c number cannot be decimals. They cannot be fractions. That's why, like I told you, you have to multiply everything by 20s, multiply everything by 10s, so you go to the decimals in the next step, that type of thing. All right. Moving on. Problem number 6, differential quotient. This problem is most definitely difficult. This one, anyway, on this practice guide. The one on the test is a lot simpler. The reason why I find this problem difficult is because the setup, what you have to do on this problem. Okay, so this is the differential formula, correct? That's what everyone should know. It's that. Now, how this works. This is your function, but you're plugging in x plus h into all these x's. And then you're subtracting the original function. So in fact, let me zoom in here so we can take a look at that formula a little bit closer. What? X plus 8? Because that's what my differential formula is. This is the formula we talked about in that third section. So it's going to be a fraction. This is the formula that they want you to use. So it's going to be some fraction with h on the bottom. That's what we're doing. H on the bottom. Now, it's my original function with this plugged into it. So, do we agree that we have a couple x's on my original problem? We need to plug in x plus h into it. So, this will be a negative 3 times x plus h squared plus 2 times x plus h minus 1. That, what you're looking at right there, that is just this piece. That's the f of x plus h. Then what am I subtracting right after that? Yeah, I'm subtracting the original item. The original function you started with was a negative 3x squared plus 2x minus 1. Okay, do you see why this is a difficult problem? That first part, that top left corner, you have to square that parenthesis. That means you have to take two parentheses, FOIL together. Once you have that, then once you FOIL that together, then you got to distribute the negative 3 into it. You do that last. Then you distribute the 2 through that, you distribute the negative sign to the back, and you simplify this all down. Okay, I'm going to give you your final answer so you know you did it right. You know you did it right if when you simplify this thing all the way down and you get something like negative 6x plus 2 plus some number for h. Like this is roughly what it's going to look like in the very end. I'm just trying to do it in my head right now. Okay, so I'm giving you the answer. So you know you did it right if it somehow simplifies into that. Now, what I mean by simplify, you have to simplify the whole top, get that all figured out, and then divide everything by h, and it should turn out to be something like this. Now, I can't tell you what this final h part is, how many h's are left, or what it's going to be. It's just a single h. I have no idea. But there's some number of h. Okay, questions, comments? Okay. Now, the reason why I want to bring this problem up is because I know that top left corner is going to be the hardest part of it, about it all. Because I know somebody's going to try to attempt to distribute that power 2 through that parenthesis. And you don't do that. You actually have to write this. You have to actually write x plus h times x plus h. And you FOIL that out. Then once that's all done, then you think times negative 3. Or that. Okay, that's this part right here. Yeah, I know that's going to be the part that's going to be. Okay, but here's my question to you guys. Is there any weird concerns or problems you're having with the initial setup? Setup on the problem. How this works, how this part works, how the bottom is. This is like the formula you have to go off of, but you're using this as your main function. That's that part. Okay. Alright. Let's go down. Okay. On this particular problem, they ask you to graph, they ask you to find the equation of the line that is perpendicular to a certain one. So the graph of that passes through negative 5, 6. Has to be perpendicular to a line that has a certain x-intercept and y-intercept. Zoom in here. All right, so my graph needs to pass through negative 5, 6. So negative 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yes. And it has to be perpendicular, so that wherever the line's going through that red dot has to be perpendicular to something going through the x-intercept of 3 and the y-intercept of negative 4. This line. Does that make sense? I need to be perpendicular to that line. So what does perpendicular mean? 90 degrees. So this is what we're looking for. We're looking for something like this where it's exactly 90. All I really need from that black line, the line that they described here, all I really need is what is the slope of that thing? What is the slope of that black line? That's what I really need. So the slope of this, well, what's that? What's this coordinate right here? 3, 0, and this coordinate down here is what? 0, negative 4. So what's the slope for that black line? What's the difference in y numbers? 4 and negative 3. 4, 3. 4/3, because it's 0 minus the negative 4, so it's 4, 3 minus 0, so yeah, it's 4 over 3. That's the slope of their black line. So if I'm doing perpendicular, this is what mine needs to be, for the red line anyway. What's my slope going to be? Negative 3/4. That's just, you need to find slope because my perpendicular line has to be the opposite reciprocal of it. And now what coordinate am I going through? Negative 5, 6, so now I can do my point slope formula. Now my point slope formula is y minus the y number, so that y minus 6, minus slope, x minus the x number. There, this is the equation that they're looking for. They want the equation, we have a graph, they're somewhat wrong. It's not accurate, but it's at least close as can be. Now, did they ask, if you read up above, did they ask you to put it in like standard form or anything like that? Just point slope form? Slope intercept, so I'll need to rearrange this. So slope-intercept formula, I'll have to distribute the negative 3/4, drag the 6 out. The slope-intercept. The big deal is, are you finding the slope of the original line that I need to be perpendicular to, or maybe I need to be parallel? If it's parallel, then it has to be the same slope. But we're doing perpendicular. So. Okay, question. Okay. So obviously there's a lot of points there. Because you have to graph correctly both lines. You have to find the equation, put it in slope-intercept form. I mean, this problem could be worth 5 points. So don't skip it. All right. So you have the rest of the class, which is not a lot of time. We can kind of work on this. Test is tomorrow. So make sure if you have questions after school today, before school tomorrow, that's the time. Don't come into class tomorrow and ask me 20 questions before the test starts. I'm not going to answer. That's not the appropriate time to ask questions. Do it beforehand. Show a little initiative.
Negative 327.
This is a good question. And double check.
Add 6.
What is it?
So we take 3 times 4 times 5, right, 25, and then add 6. Or, that's easier.
So 30 seconds.
Not gonna lie when I say I'm really disappointed I didn't get them all.
Sweaty crayons? Hey, what did you have you filled this out yet? Yep. Did you do the business one? Nope. What mistake have I made?
Okay, what are we doing?
You gotta make your mistake positive.
Nerd physics?
You can't make it like an actual
Talk
mistake.
about the
You're
same problem for the entire class period.
Doing homework?
Okay, yeah, but still wish I put
gonna-
And the test is not, or the quiz is not Friday.
It's not one yet.
Probably.
Here you go.
I was hoping it was like
See if you can make it